I want to discuss about the basic probability. Basic probability. So, how do you define the probability of event A? It is number of points in the event A by number of points in S. Let's see what's the probability of the event A. It is the number of points in A by the number of points in S. So, you will definitely get questions on these concepts. Now, this has certain standard results, like we say axioms. This P of A satisfies certain standard results. What are those standard results? The first one is 0 less than or equal to probability of A less than or equal to 1. The second one is the probability of the sample space is 1. The third one is for mutually exclusive events. For what events? For A intersection B equal to null set. For A intersection B equal to null set, we have this interesting result, that is P of A union B is equal to P of A plus P of B. So when you have mutually exclusive events, the probability of the union is equal to sum of the individual probabilities. Now this was explained to you in classes in a detailed way. So these three are the axioms, students. Apart from this, there are some basic theorems like complement rule. According to complement rule, the probability of A complement is 1 minus probability of A. And then according to the addition theorem or addition rule, the probability of A union B is P of A plus P of B minus P of A intersection B. You can also extend it for three events. Probability of A union B union C is probability of A plus probability of B plus probability of C, where you have sum of all the individual probabilities, and then minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A. So, and then like A intersection, like intersection of two events we have covered, and then plus it is probability of A intersection B intersection C. So this is called the addition rule. Hope you have this idea. So what next? There are few more theorems I would like to quickly revise and then solve problems on them. So let's quickly revise few more things. So yeah, so we have completed the basic definition, axioms, complement rule, addition rule, multiplication rule, like the conditional probability, multiplication rule and the Bayes rule. These are really important. So what is conditional probability? In every class I ask you this question, what question I ask? How do you read this probability? So let's see some answers. I asked almost all students whom I taught, how do you read this? Can I get some answers? You people can use a chat section. Arey, come on, read this. So let me read this. Given that the outcomes are only from B, what is the probability of A? This is how it is read. Students, there are many instances where they'll not give you this expression P of A by B. but they'll give you a sentence. Given that the outcomes are only from so and so set, what's the probability of, so yeah, given that the outcomes are only from B, what's the probability of A? They'll give you a sentence. You have to decode and say, look, this is conditional probability is what they are asking. And what is expression for that? It is P of A intersection B by P of B. Same way, what is P of B given A? It is P of A intersection B by P of A. And how do you read? Given that the outcomes are only from A, what's the probability of the event B? These two terms are called conditional probabilities. So there are some special cases. Let me discuss those special cases. So what is the heading, students? Conditional probability. Okay. So some special cases I said, na. So what do you mean by special cases? I'll show you. Case 1, if A intersection B is a null set, then the probability of A intersection B is 0, and the conditional probabilities like A by B probability is 0, B by A probability is also 0. Most of the students have a doubt, sir, how to identify whether the events are mutually exclusive or not. If A and B are mutually exclusive, then A intersection B is null set. The probability of their intersection is 0. The conditional probabilities are also 0. Now comes the most important step. If A and B are independent, you will get one question on independent events. So if A and B are independent events, then probability of A intersection B is simply probability of A into probability of B. And do you know what are the conditional probabilities? A given B probability is directly probability of A. The probability of B given A is directly P of B. This is a very important point. I hope you people know this. I hope you people like have a great knowledge of these concepts. Great knowledge means the moment I say independent events, the moment I say mutually exclusive, instantly you know what to do. So that's what we want in the exam. I'll put this for a minute on the screen. Just observe these things. I want the computer science and the data science students, everyone, to qualify the exam. And especially, I'm focused on data science students. I've been training all the data science students for the engineering mathematics subject. I'm requesting you people, you have to qualify the exam. The qualifying is very easy. So that's the first target. The second target is to score as many marks as possible. You can go through this for a minute. Okay, next. So the next concept is called multiplication rule. Multiplication rule. So P of A intersection B can be written as P of A by B into P of A. This is for two events. You can write for three events also. A intersection, B intersection, C. So for example, I treat this B intersection C as a new event called D. So this is like P of A given D, which is B intersection C, into P of D, which is B intersection C. P of A given B intersection C into, this can further be written as P of B given C into P of C. You can write this for uh, 4 events, 5 events, and so on. This is called conditioning, students. What is this called? Conditioning. So we write the intersection probabilities in terms of the conditional probabilities. And in the case of independent events, so look at this, if A1, A2 up to AN are independent, then the probability of A1 intersection A2 intersection up to AN, this is P of A1 into P of A2, so on, P of AN. The probability of the intersection is equal to the product of individual probabilities in the case of independent events. So now the Bayes rule. 100% you will have a question on this concept. What did I say? I said 100% you will get a question on this concept. So it's better you should know how the theory is related to Bayes rule. So if you have attended my classes, I would have said, just imagine one sample space, divide that into mutually exclusive events. Do you remember that discussion? So what I used to say is, imagine one sample space like this and divide this into what? Mutually exclusive events. Name them B1, B2, let's say this is BI, and then let's say this is BN. Imagine there is a sample space which is divided into n mutually exclusive events. Mutually exclusive means there is nothing common here. If you take the intersection of B1, B2, null set. B1, Bn, null set. Any two events you take, their intersection is null set. At the same time, when you take the union of all of them, it's a sample space. So what is this? This is the sample space, students. Now, what we do is, we define an event called A. So what is this event called? A. Whatever I have marked in this blue, that is A. I want what is probability of A. How do you find probability of A? And you know what? In the exam, you should be very alert. So all the skill is about identifying the event A. So how do you identify the event A? So for that, we have solved many problems. So there will be a discussion on a particular event every time. So you have to identify that event A. So now, how do you find the probability of A, students? How do you find probability of A? If you want to find the probability of A, then write like this. Probability of A is the probability of this portion, which is A intersection B1, plus the probability of this portion, which is A intersection B2, and then so on. The probability of this portion, like so on, the probability of this portion, that is probability of A intersection Bn. Further, what you do is, you write this in conditional probabilities, like A given B1 into probability of B1 plus A given B2 into probability of B2 plus so on, A given Bn into probability of Bn. This is called the total probability. This is called total probability, or simply the probability of the event A. In the exam, if you can get this quickly, it's like almost we have solved the problem. So now what next? The Bayes rule. So what does the Bayes rule tell? Look at this. How do you read this? given that the outcomes are from A. How do you show it? Given that the outcomes are from this set, not from anything else, not from the sample space. If given that the outcomes are only from the reduced sample space A, what's the probability that it came from B1? So what's the probability that it came from B1? Given that the outcomes are only from this, what's the probability that it has come from B1? This is what you have to find. So how do you find it? First, so what you have to do is you have to look at what is probability of this, and you have to like select what is probability of this. So the probability of this by probability of this will be our answer. So that is, so what's this part? This part is A intersection B1, which is written as probability of A by B1 into probability of B1. So this is probability of A given B1 into probability of B1, and then divided by this whole big expression. So please write this, and I have been training students that maybe here I have taken n events in the exam. Most of the time only 2 events were asked. So hardly you'll get 2 terms in the denominator. You have to anticipate these questions. You have to write the answer instantly. That's all about the preparation, right? If your preparation is very good, you will do all these things in a great way. So come on, it is A given B1 into P of B1 plus A given B2 into P of B2 plus so on, plus probability of A given Bn into probability of Bn. So this is the answer. Same way, if I ask you what is B2 given A, if I ask you what is probability of B2 given A, B2 given A, you know what? The denominator remains the same. So what's the denominator? A given B1 into P of B1 plus A given B2 into P of B2 plus so on, A given Bn into probability of Bn. The denominator remains same. The second term which is related to B2, which is written here, you have to just place that in the numerator. The probability of A given B2 into probability of B2. I hope you got an idea about the Bayes rule. So what else can be discussed? These are the main things. Statistics part can be discussed. Statistics part will be discussed with you now. And I'll also solve the questions on these topics. Just give me some time. Let me complete this statistics revision. How do you find the mean? You say, if observations are given, sum of the observations by number of the observations. This can also be written as summation I from 1 to n xi by n. This is how you find. But how do you find if a discrete random variable is given? If a discrete random variable is given, it is calculated as summation over all the values of n. It is, or summation over all the values of x, let's say. It is x into the probability of x. Suppose if a continuous random variable is given, integration minus infinity to infinity x f of x dx. So already we have discussed these things in the random variable section, but if only observations are given, this is how we find sum of the observations by number of the observations. So how do you people find the median? How do you people find median? You all know, if observations are given and odd number of observations are given, you will arrange those observations in ascending order and pick the middlemost element. If even number of observations are given, then there are two middle values, you will take the average. This you have been learning from many days. If continuous random variable is given, how do you find the median? That is very interesting. For the discrete random variable also, it is interesting. Let me write for discrete and continuous. So for discrete random variable, what we say is the probability of x greater than or equal to small x must be greater than or equal to 0.5, and the probability of x less than or equal to small x should also be greater than or equal to 0.5. If you are able to find such observation which satisfies this criteria, now that observation x is called the median. This observation x will be called the median. So this is for what kind of random variable? For discrete random variable. You can put the heading as discrete random variable. For a continuous random variable, students, we check this. The probability of x greater than or equal to small x must be exactly 0.5, and the probability of x less than or equal to small x should also be exactly 0.5. So what's the next topic? Mode is the next topic. So how do you people find mode? If observations are given, then you will say the observation which repeats for maximum number of times, the observation which repeats for maximum number of times will be called the mode. So let's fill that here. The observation that repeats for maximum number of times. If discrete random variable is given, then you will check for that probability, like you will check for the maximum probability, and the corresponding observation will be called the mode. So here x will take a lot of values, you will see which is the uh, largest probability and the corresponding observation. Now the corresponding observation with largest probability is called mode. And how do you find mode for a continuous random variable? So you will see where is the probability density function taking a maximum value. So in the case of a Gaussian random variable, look at this. Suppose if a data is given to you like this, a symmetrical data where this is the mean. So you will see where is this density function going a maximum value. So here is the density function going to a maximum value, that is mu. In this case, the mean is equal to median is equal to mode. So for this case, mean, median, mode are same. But if I change if I change the density function, the answer might change. So here, if a continuous random variable is given, we use the maxima minima concept. So if f of x is given, find the derivative, equate the derivative to 0, get stationary point. So from that stationary point, substitute that stationary point into the second derivative. Based on the sign, decide whether it is maximum or not. If the second derivative is less than 0 at that stationary point, so definitely you will have a maximum. So that corresponding observation will be called mode now. That corresponding stationary point where you are having a maximum is called mode. So these things can be asked. So maybe here I would like to give you a recap of this data. How many of you remember this, and what do you call this data as? People, do you remember this? Is this a symmetrical graph? Bolo, what kind of graph is this? It is left skewed because you have a larger tail on the left side. So look at this graph. The larger tail is on the right side, the larger tail is on the left side. This is left skewed data. left skewed and right skewed. So how do you mark the mean, median, mode? Now to whatever side you have the larger tail, that side you will have the mean. So here you will have the mean. This is obviously the point where you see the maximum. So this is the mode. Always in between you will have the median. In between you will always have the median. Now what about the right skewed? Exactly opposite. So opposite means this go like this. Towards the larger tail, again the same observation, you will have the mean towards the larger tail. So mean will be here. Wherever you see a maximum, that's like a mode, and in between you will have the median. This is also expected. If the data is symmetrical, there is a chance that mean, median, mode can be equal, but here there is no such symmetry. So next, what is variance? Variance of x. Variance of x is expected value of x square minus expected value of x whole square. How do you find the variance? So how do I find this? You already know how to deal with the discrete random variable and continuous random variable, but when observations are given, this E of x is simply summation I from 1 to n, it is xi and then by n. How do you find expected value of x square? It is summation I from 1 to n, it is xi square divided by n. This is how you deal when observations are given. So you substitute them, you get the answer. Now, what is the standard deviation? This is one of the most important things. Standard deviation is defined as the square root of variance. So variance can never be negative, standard deviation also never negative. What does this standard deviation tell you or the variance tell you? So it tells or it gives you a measure like how is the data spread out from the average value. Is there a larger spread from the average value, or is your data like centered, or it is most of the data is near the average value? It gives you that observation. Higher the variance, higher is the spread of the data. These things can be asked in your examination. So this is about mean, median, mode and the standard deviation. A quick recap. You can just go through this. I'll keep this for a minute. This question was very well created. I want to solve that. I'll show you the question. I have solved these questions in the classes also. Is this visible to all of you? For the live streaming, there might be a little blur, but I think it is readable. For me, it is readable from here. I'm also looking into the live session. I have a laptop in front of me. So in the laptop, it is readable for me. A class contains 60% students who are incapable of changing their opinion about anything, and 40% of the students are changing their minds at random with probability 0.3 between subsequent votes on the same issue. Then the probability of a student randomly chosen voted twice in the same way is. So you can go through the data, read the question multiple times to get a better understanding of the question. There is a class, out of the 100% students, 60% students are there who are incapable of changing their opinions about anything. Incapable of changing their opinion means once they decide something, so every time you ask them, they are with the same opinion. And 40% of the students are changing their minds at random. So the remaining 40%, you have like they say something in the beginning, and after some time you ask them, they might change their opinion. That's what they are saying. And that too with probability 0.3. So it means 40% students remaining 40%, they all are not changing their opinion. In that 40%, with 0.3 probability, they are changing their opinion. This is little tricky to decode. The probability of a student randomly chosen voted twice in the same way. So, some of you would have already solved this. So, how do you solve it? How do you solve it? A class contains 60% students who are incapable of changing their opinion. Now, if you select any student from this, so first time, however, like the way he voted, in the second time also he votes in the same way because he is incapable of changing their opinion. So, the required answer is it is 0.6 plus. In this 40%, point with probability 0.3, they are changing their minds. Changing their mind means, suppose if I have voted for a person A, next time when you asked him to whom you are voting, he'll say I'll vote now to B. So this happens with what probability? This happens with probability 0.3. Now that means, what's the complement of this? With 0.3 probability he will change the opinion. With 0.7, now how do you know 0.7? 1 minus 0.3 is 0.7. With 0.3 probability he will change the opinion. With 0.7 probability he will not change his opinion. So plus 40% means it is 0.4 into, now among this, with 0.7 probability he doesn't change his opinion. So this is 0.6 and this is 2.8, which is 0.88. When I read this problem, students, frankly, the first time, I had a lot of confusion, like what exactly he wants. Only after reading it 2-3 times, I could write this answer in a single line. Not only me, you people would have also been in that situation. So if you are getting questions on probability, don't panic. Please don't panic. Have some patience, and then reading multiple times can help you. So students, I can show you one observation. I'll show you one observation. This will definitely help you. Why we check these resources carefully is, I'll show you one comparison. This is the sample paper which was released before 2024 examination. The mean of the observations of the first 50 observations of a process is 12. If the 51st observation is 18, then the mean of the first 51 observations of the process is. So let me take this question and put it on the screen. So this is from the sample paper. So what does he say? The mean of the observations of the first 50 observations of a process is 12. According to him, summation I from 1 to 50 xi by n, that is 50, how much is the mean? According to the question, it is 12, it seems. This is 12. So summation I from 1 to 50 xi, that is sum of all the observations, will be like 12 into 50. And comes the 51st observation, which is 18. Now he wants mean of the new data. So how do you find the mean of the new data? So you have to add all your observations like x1 plus x2 plus so on x50 plus x51 by 51. This is what you have to find. Now we don't know what is x1, x2 up to x50, we don't know, but we know sum of all of them. That is x1, x2 up to x50, you know how much? It is 12 into 50. So it is 12 into 50 plus the 51st observation is 18 and then by 51. Can you give me a answer? So which is one of these? You first tell me how much is the decimal value. Nishant says it is 12.117. 117. Are 12.36 is there? 12 point. Come on, majority, what is your answer? Can you find the decimal value properly and pick the appropriate option? Option B, that is 12.12 approximately. Now, why am I showing this question? Just go through this half minute, I'll give you why am I showing this question, you'll understand. Yeah, so what's the reason behind this question is, this is from sample paper. Which paper? Sample paper, before the exam, few months before they gave. Now, GATE, let me type GATE here, GATE 2025. Go to this, go to downloads, look at your data science 2024 actual exam paper, data science. Look at this question. Arre, what is this? They gave exactly the same problem. The sample average of 50 data points is 40. The updated sample average after including a new data point taking the value of 142 is dash. Exactly the same question was asked. Why I'm saying all this is, if you have already solved certain questions, if you have solved GATE 2024 paper, analyzing GATE 2024 DA paper is very, very important. Each and every question you have to solve it. You have to see all possibilities, how different questions can be created from that, because these things are expected. Not only this, there are many instances where the previous year questions got repeated the same, like some numerical change would be there, but the pattern is the same. So you should analyze these problems. Which problems I'll tell you, especially DA 2024 paper, the sample paper, the computer science previous year questions, you are supposed to analyze these things. If you analyze, some questions you can solve just instantly. So let me proceed and check any other questions that can be solved. Yeah. So I wanted to ask you one important thing. Students, let's say this is A, let's say this is B, this is the sample space. If I ask you what is A intersection B, so you will show me this. If I ask you what's the probability of at least one event, what will you find? What is the probability of at least one event? At least one event, then what are you going to find? Probability of at least one event. Let's ask the students. Lakshman says, is this for CS? Yes, CS also. You have all this for CS. I will tell you when I start the special topics which are only for DA. So let me solve some more questions and then the syllabus will be over for computer science. What's the probability of at least one event? Can someone reply? Satvik says it is P of A union B. Ayush says A union B. Yes, you're all right. It is P of A union B. And you know how to find it? It is P of A plus P of B minus P of A intersection B. Let me ask you this question. How do you find P of A intersection B complement? How do you find P of A intersection B complement? Come on. Can anyone give me the expression? A intersection B complement. So what shall I do? I'll shade B complement. Let me shade B complement. So where is B complement? Let's put this A inside. Let me shade B complement. So what is this? This is B complement. But what I want, the common part of A and B complement. What's the common part of A and B complement? It is this part. I hope you can check this. What part? It is this part. How is this part calculated? It is probability of A minus probability of A intersection B. So I'm not saying like only these things will be asked in the exam. Similar things can be asked. Sometimes the Venn diagram approach can give you the answer. So please remember this, Venn diagram approach can be very helpful for you. So what next? I'll put one question. So let's see whether you will be able to solve or not. I'll just minimize this for your reference. All these things were already discussed in our classes. I'm just highlighting that these are important for your upcoming examination. Can you people solve this and give me the answer? Hope this is visible to all of you. Come on, please solve this and give me the answer. So, looks like some of you have already answered it. So, what is asked? The conditional probability of T given S is asked. So, it is T intersection S by P of S. Is P of S given? No. Is P of T intersection S given? No. You have to find these two quantities using this information. So let me use this first information. What is the first information? P of S given T, which is probability of S intersection T by P of T. And how much is this given? This is given as 0.3. We know the denominator value because P of T complement is given. You can extract the numerator, that is P of S intersection T can also be written as T intersection S by probability of T is 1 minus 0.6, which is 0.4, which is equal to 0.3. So from this, what is the probability of T intersection S? It is 0.3 to 0.4, it is 0.12. They gave another information. So please look at what is the other information, students. The other information is P of S given T complement, which is probability of S intersection T complement by probability of T complement. And how much is this given as? It is given as 0.6. Do you know the denominator probability? Yes, we know. Do you know how to write the numerator? Yes, I know. So how do you write S intersection T complement? Will you write like this? It is probability of S minus probability of S intersection T by the probability of T complement. Probability of T complement is 0.6 and it should also be equated to 0.6 because here we have 0.6. 0.6 goes to the other side. The probability of S minus this S intersection T or T intersection S is 0.12. So minus 0.12 equal to 0.6. The probability of S is 0.6 into 0.6 now. Here not, it is 0.6 into 0.6. So this is 0.36 and this is 0.12, which is 0.48. We have got all the things that we want. So it is the numerator. How much is the numerator? 0.12 divided by 0.48, 1 by 4, which is 0.25. You should anticipate this kind of questions and you should be very quick with the problem solving. Lakshman, please check your answer. So this is the procedure involved. I'll give you a half minute, please go through this. Okay, so let me show you few more questions. This is the Computer Science 2024 paper. So please go through this. Consider a permutation sampled uniformly at random from the set of all permutations 1, 2, 3, 4 up to n for some n greater than or equal to 4. Let x be the event that 1 occurs before 2 in the permutation and y the event that 3 occurs before 4. Which one of the following statements is true? The events x and y are mutually exclusive. The events x and y are independent. Either event x or y must occur. Event x is more likely than the event y. So I'll give you 2 minutes time. Can you give your response? I'll also create a poll. So students, please reply in that poll. So let's see. He said there is a set which contains 1, 2, 3 up to n. There are n elements in that. And he's arranging all those n elements. So how do I know? He says permutation of 1, 2, 3 up to n. Permutation means arrangement. What is x? That 1 occurs before 2 in the permutation and y is the event that 3 occurs before 4. Let me just see. Let me cover the event x. Can I take n as 4 or can I take n as 5? Nothing, na? I mean, no problem, na? I'm asking. No problem. I can take n as 4. Then you will have a set like 1, 2, 3, 4, 5. Let's take one of the permutations. So he says 1 occurs before 2. 1 occurs before 2. Okay. 1, 2, 5, 4, 3. This is something which belongs to x. Sir, how do you say that this belongs to x, sir? Because this is a permutation of 5 numbers. Sir, why you took only 5? Because I am just doing the verification. So 1 occurs before 2. This has to belong to x. Let me also create some event which belongs to y. 2, 1, 3, 4, 5. 2, 1, 3, 4, 5. This is also the arrangement. Can you see that 3 is occurring before 4? 3 occurs before 4. So this is something which belongs to y. So like that you have to check all the permutations, see what elements belong to x, so what elements belong to y, and then you have to answer it. Now look at this, will this also be a permutation? 1, 2, 3, 4, 5. Yes, this is also a permutation. 5, 1, 2, 3, 4. Yes, this is also a permutation. You know what? These kind of arrangements belong to x as well as y. This belong to x as well as y because 1 is occurring before 2, so it has to be part of x. 3 is occurring before 4, it has to be a part of y. So x and y are mutually exclusive is ruled out. What is ruled out? Mutually exclusive thing is ruled out. The events x and y are mutually exclusive is clearly false. And then he says either event A x or event y must occur, but I said they can simultaneously occur, na? If you choose this 1, 2, 3, 4, 5, here the event X is occurring, the event Y is also occurring. He says either X will occur or Y will occur or must occur, he says. This is false. Now, the events X and Y are independent. Event X is more likely than the event Y. So, event X is more likely than event Y. He clearly said n is greater than or equal to 4. You have to take 1, 2, 3, 4 elements for sure. Now, in that situation, so 1 occurring before 2, the number of points in which 1 occurs before 2 will be exactly equal to the number of points in which 3 will occur before 4. They are equally likely. They are independent. I hope you are following. Suppose you say that your set is 1, 2, 3. You don't take 4, let's say. Then 1 occurring before 2 will be more than 3 occurring before 4 because you have not taken 4. But this case doesn't arise, because you are not supposed to take 1, 2, 3. You are supposed to take at least 1, 2, 3, 4. In that situation, the number of times 1 occurs before 2 will be equal to the number of times 3 occurs before 4. They are equally likely. But he says event X is more likely to occur than the event Y are a false statement. It's a false statement. Okay. Next. The events X and Y are independent. Yes. 1 occurring before 2 is independent of 3 occurring 4. This is absolutely true. This is a fantastic question which was asked in your Computer Science 2024 paper. Hope you people have understood. So let me see any other questions can be taken from probability. Is this a MSQ? This is a MSQ. Let A and B be two events in a probability space with P of A as 0.3, with P of B as 0.5 and A intersection B as 0.1. Which of the following statements are true? The two events A and B are independent. Probability of A union B is 0.7. Probability of A intersection B complement is 0.2. The probability of A complement intersection B complement is 0.4. You have to identify which of them is correct. Can you people identify it? I'll give you 2 minutes time. I'm giving you 3 minutes time. So please identify this. Majority answer is B and C. For independent events, you have to check this. Is this equal to P of A into P of B? What is P of A into P of B? 0.3 into 0.5, which is 0.15 na? So what is P of A intersection B? 0.1. So clearly this is not true. So what we understand is this is not equal to this. Now when P of A intersection B is not equal to P of A into P of B, they are not independent. So two events A and B are independent is false. And then A union B probability is asked, which is very simple to find. P of A union B is P of A plus P of B minus P of A intersection B. All the information is given. P of A is 0.3, this is 0.5 minus 0.1, 0.8 minus 0.1 is 0.7. True. A intersection B complement. I have revised this formula also, P of A intersection B complement. You can use a Venn diagram, but I mean, since I have already solved, I know P of A. I have also revised you people, not like I'm just writing it directly. I have revised just now. So it is minus P of A intersection B. What is P of A? 0.3 minus A intersection B, 0.1. How much is the difference? 0.2. Yes, true. This is true. And the last one, P of A complement intersection B complement. Can someone guide me? How do you people find P of A complement intersection B complement? I want to see your ideas. P of A complement intersection B complement. Bolo. Can you give me idea so that I'll solve? P of A complement intersection B complement. I don't know how to solve this. Let's ask the students to give us the ideas. So P of A complement intersection B complement is, yes, 1 minus P of A union B. 1 minus this P of A union B is freshly calculated as 0.7. So 1 minus 0.7 is 0.3, but they wrote 0.4, which is not matching. This is false. B and C are the answers for this question. The majority was right.